Okay, so we're going to have a look at some differences in sleep across our lifespan. So particularly differences in the lifespan in terms of the total amount of sleep and changes in typical patterns. So the proportion of non-REM and REM within people of all different ages. So sleep across your life. So lots of things in terms of our sleep changes with age, and we've just had a look at those different theories and how they can apply to different parts. So for example, newborns need 16 hours of sleep per day, and 50% of this is going to be REM. So REM sleep helps with brain development, which is why infants need so much, because their tiny little brains need to develop. So their REM to non-REM sleep is 50-50. Adolescent, so typical adolescent needs 9 hours sleep with 20 to 25% of that being REM, and adults 8 hours with 20 to 25 being REM as well. People over the age of 60, so elderly, 6 hours of sleep with 20 to 25% being in REM. However, there's a lot less time spent in stage 4, if any. So as we age, we have lighter sleep, and as we age, we need less sleep. So think about it like that. So we're going to have a look at some patterns that are characteristic of elderly people. So here's a lovely graph here where we can start to have a look at some of those portions. So it's a little bit hard to break down. So let's go here. So this is the total sleep per day. So we've got our infants here, all starting at 16 hours per day. And the amount of REM that they need. So we know we just spoke about it being 50-50 here at the start. And so we can see that REM's slowly decreasing, and the hours that we stay awake increases over time. So let's have a look at adolescence. So here's the age bracket here. So 14 to 18, which is what you guys fit into. So 20% of REM. And yeah, we've got 9 hours sleep here, which is what is needed. Let's have a look at typical adults, because that's another one that comes up a lot. So about 8 hours here, and again with roughly 20% of REM to non-REM there. So great graph in terms of having a look at how long each of these different groups need to sleep a day and the percentage of REM. So this table you need to learn off by heart. It is imperative. It's a very important table. Just kind of summarizes some of those points in terms of the amount of REM and non-REM hours. And we're going to use this as a little cheat sheet for some hypnograms. So a couple things here that reiterate, you can copy those. I'm just trying to make the videos as short as possible. Okay, so old age, and this is a very useful exam tip. So if you're asked to compare the proportion of REM and non-REM sleep across the lifespan, you don't always have to mention features such as sleep duration. So you don't need to know the exact proportions, but rather the approximate differences between groups. So if I'm reading a hypnogram and I'm trying to figure out how long the sleep is exactly, or how long that period went for. So say, for example, here, you don't need to be able to identify that block there, which is about an hour and a half. What was the other thing I was going to say about old age? We'll get to it as we have a look at the hypnograms. Okay, so again, we're looking at hypnograms. So this is data from an EEG converted to have a look at typical patterns of a young adult and an elderly person. So as you would have just seen in the notes that you've taken, elderly people have less sleep, and it's characterized by a lot more awakening. So see all these little brief awakenings here, and no deep sleep, or not much deep sleep. So that's always going to be the easiest way to tell if it's an elderly person. Lots of little awakenings and not much deep sleep underneath there. And then we'll go back here for a typical healthy adult. So things that we're going to look out for here is deep sleep in the first half of the sleep cycle. We can see the REM increasing as it goes there, and the non-REM decreasing. So you've also got from PowerPoint 4, slide 34, where you took some notes about typical night sleep. So things like how many ultradian cycles occur, or average duration, portion of non-REM to REM. So this is consistent there with the REM being 20% and non-REM being 80%. So another one here, whoops, it already says what they are on there, but that's okay. So this one here, we're going to be able to tell that it is a child because of these longer periods of deep sleep that occur at the start. So it's not as common if you have a look at for adults or adolescents here. We wouldn't be in deep sleep for as long as children would be. So that's a good thing to compare there when you're looking at trying to figure out how that one will be a child and how that one will be an adult. That would help you. And also adults having more awakenings than the child, which is common there to see. And here again is that elderly pattern, which is characterized by not much deep sleep and all of these awakenings. So let's get into some questions here. Joseph is a healthy newborn baby and Gabby is a healthy 65-year-old. So notice the word healthy. So we're looking for those typical patterns and those textbook things that we've learnt there. Which of these graphs represents the amount of time spent in non-REM and REM in a typical 24-hour period for Joseph and Gabby? So we're going to look at each of the four graphs and then figure out which ones apply to Joseph and which ones apply to Gabby. So if we can scroll back and go back to your table, you need to know it by heart. So we're looking for 8 hours of sleep in REM and 8 hours in non-REM for baby Joseph, and 1 hour to 5 hours, so not as much, a little bit under that 20% of REM there. So let's go back to here. So we're looking for healthy newborn baby 50-50, so 50% REM and 50% non-REM. So let's have a look at these graphs here. So this one here is not proportionate. Graph 1's not proportionate. Neither is graph 3. Neither is graph 2. Graph 4, so 50% REM and 50% non-REM, which means that graph 4 has to be for baby Joseph, because that's the type of sleep he needs. So we can already cross out A and B. And so now for Gabby, we just need to have a look at graph 1 and graph 3. So let's go back to, we know that an elderly person is about 1 hour REM to 5 hours of non-REM sleep. So if we have a look here, we can see that this one, it totals the non-REM sleep in 8 hours and that 2 hours. So that's a 10 hour sleep. Whereas this one here is, what's that, about 5 hours and then 1 hour. So graph 1 is going to be our winner here. Because of the amount of sleep time in total, it was easy to be able to tell that proportion. Identify the age group based on the hypnograms provided. Ooh, okay, so first thing we can do here is have a look. Okay, so we've got some deep sleep here. We've got some REM increasing. We've got a couple of brief awakenings. Sleep is for about, 8 hours there. Now let's have a look at our other graph. We've got some really deep sleep at the start there. We've got some REM and 11 hours of sleep. Okay, so the fact that this is 11 hours and these long deep sleep periods is going to tell me that graph B is a child. And graph A is going to be an adolescent or an adult. Oh my gosh, I can never spell adolescent. You know I'm not good at spelling. So why is that? We can see the REM increasing. We can see the deep sleep in the first half and those brief awakenings. So it's going to be adolescent, basically mainly because of this 9 hour. If it was a bit less, I would say an adult, but without more information, it could kind of be either. Question 9. So the figure is a hypnogram representing the sleep cycle of a healthy adolescent. Okay, so it's already told me that it's an adolescent, so thank you, that's nice. And this is adapted from a Vika question too. So outline 2 differences between REM and non-REM as evident in the hypnogram. So you can't go ahead and talk about everything you know that's different between REM and non-REM. You need to relate it to what you can actually see in the hypnogram here. So we know that we can see here is that REM increases and non-REM decreases as the night goes on. And remember, it's asking for two differences. This is only one difference because you're comparing those two things, which makes it one. And difference number two, simple one. There's only what am I saying? There's 4 stages of non-REM, and there's only one stage of REM. That's a cheeky one that you can do. Okay, and let's look at B. Explain how the hypnogram of a healthy infant... Oh, that's sorry about my dog barking. I think some mail just got delivered and it's probably for me. Explain how the hypnogram of a healthy infant would differ to this hypnogram of a healthy adolescent. So what would be different if it was an infant? So we could talk about the period of REM sleep. So we know it's 50-50 in infant, so you need to explain that. How it be more for an infant, you can just say why if you want to. And another difference as well, we could talk about the duration of sleep. So as we age, it decreases, whereas a healthy infant would sleep for about 16 hours a day. Gosh, I wish I could sleep for that long. Okay, last question. You know I love doing questions from my exam year, 2011. So this is taken from a direct Vika question. So, the following graphs show the typical sleep cycles for 2 distinct age groups. Okay. 2 age groups here, and then there's 2 questions relating to them. So let's have a look at a couple of features to try and figure it out. So 9 hours sleep, so we're going to say potentially an adolescent or an adult, deep sleep at the start, REM increasing, couple of brief awakenings. And let's look at the other graph. So what's it characterized by? Not that much REM. We can see here lots of awakenings, and yeah, it's about, from those awakenings there, about 7 to 8 hours of sleep in total duration there. So question 7. The typical sleep cycle is represented in graph 1 and 2 in order. So first one, A, an infant. Neither of these are going to be an infant because of the timing in terms of the duration, and there's not a proportionate amount of REM to non-REM. So it's not going to be A, and then it's not going to be B because we know it's on infant. C, so the first one here being an elderly person or an infant, well, we already discovered it's not an infant, which leaves us with D, which we know that this is typical for an adolescent, graph 1, and graph 2, because of all these brief awakenings and not much deep sleep here, we know that the answer is going to be D. So first one's an adolescent, second one's an elderly person. Next question. According to the restorative theory of sleep, the sleeper in graph 1 spends more time in REM sleep than the sleeper in graph 2 because they are experiencing REM rebound. Well, we don't know that. Their sleep-wake cycle has shifted forward due to their age. That's true. C, neural connections in the brain are strengthened during sleep. That's also true. Experiencing more sleep at night enhances the survival. That doesn't really apply to here. So we need to go back now because it's very easy to think that the answer is B. But we need to go back and read the question. According to the theory of sleep, the sleeper in graph 1 spend more time because of. So it's asking us to relate it back to the graph and comparing these two things. So if we said B, while that's true, that doesn't compare it to what's happening in graph 2, which makes the answer of this one C. neural connections in the brain are strengthened during sleep. So we're spending more time in REM during that adolescent period as our brain's developing, more time than when we are elderly. And so here's the advice from Vicky there. So it is true that sleep-wake cycle has shifted forward due to their age, but it doesn't explain why graph 1 spends more time in 2. So looking for that connection there, being able to apply it to the scenario and to the question.